Whew. It's hot out. Anyone else hot? To really understand climate change, we need good, solid data over time. For 50 years, the Landsat missions have surveilled, eyeballed, snooped, and even stalked the Earth from space, mapping both man-made and natural disasters, giving climate nerds the world over unique scientific data to monitor, understand, and manage Earth's natural resources, and possibly one or two screensaver backgrounds. Did I mention that NASA makes this data absolutely free? Not $19.99, not even $9.99, but free. Critical science data at bargain bin prices. Who loses? Order now.
Welcome to NASA Edge.
An inside and outside look at all things NASA.
We're coming to you live today from the Vandenberg Space Force Base. Blair, not the Air Force Base, but the Space Force Base. The name was officially changed this past summer.
And I got to tell you, I'm just giddy because I've always wanted to work at a Space Force base.
Well, today you can say you did that.
Tell you, in addition to the guests we have on our show, Franklin, we're going to be seeing tower rollback. Out at Space Launch Complex 3, the mobile servicing tower is going to roll back and reveal the rocket taking Landsat 9 to space.
Yes, well, Landsat 9 is the focus of our show today, and the launch of this satellite will continue a long history of Landsat missions from NASA.
That 50 years of data, I got to tell you, the pressure's on, but I think NASA today will deliver.
Absolutely. But before we get into our show, I want to talk a little bit about the cameo that I know I saw you in at the beginning of our show.
I don't know. You think that's me?
Absolutely.
I mean, we share a common hairline, or, and maybe sort of in a funhouse, nerdy, geeky kind of way, maybe. But I say polar opposites, or at least they won't let me operate that equipment.
Well, you know what? We'll talk a little bit more about that as the show goes on. But right now, let's take a look at the pad feed. And when we come back, I'll be sitting down with Bruce Cook, the Deputy Project Scientist for Landsat 9. Bruce, we hear so much about the types of, natural disasters and man-made things that Landsat can see from space. But talk about some of the more positive aspects of what Landsat can do.
Yeah, so unfortunately, it is true that that Landsat does pick up a lot of things that we see: the disasters, we see floods, we see fires. We see a lot of things that the news picks up that maybe is harmful in the environment. Water quality that's deteriorating. We see melting of ice and things like that. But it's what we do with those observations that's important. It's the decisions that we make from these observations and how we respond to these observations that's important. And so that's what the Landsat data does. It allows us to make decisions based upon these observations. If we can't make these measurements, we can't make good decisions. And that's what Landsat's always been about, is measuring our natural resources so we can make better decisions into the future.
How do the global observations that Landsat makes, how does it help local agricultural decisions?
Yeah, so agriculture is an international marketplace these days. So as we learned back in the 70s, when we produced an excess amount of wheat, but there was a global shortage of wheat, we learned that there's a need to have an eye on the markets of agricultural products. Agriculture is a global commodity. We buy products, we sell products globally. And so it's important that we know what products are being produced globally, how much agricultural land there is out there, so that we can feed the world, so that we can respond to crises when they happen, so that we can respond to famine, so that we can respond to crises as they happen, and be proactive in terms of sending relief aid to countries that need it.
What is the turnaround time for receiving data from Landsat 9? And how has
Yeah.
that increased over, the previous satellites?
Yeah, it's pretty incredible. In 1972, there was no data storage on board some of these satellites. And so data was sent down, and then it would have to be mailed actually to centers that would do the analysis. And at those times, even just visualizing the data that was coming from Landsat, there were no personal computers. There were no computers that could do the visualization processes. And so a lot of that had to be done by hand. Nowadays, the data is delivered and in the hands of the stakeholders, the people that are using the data, within hours after the data is collected. And that's just game changing, because people can make decisions so much faster these days.
Well, that's great information, Bruce. We wish you all the best for a successful launch today.
Thank you very much. Yeah, it's an honor to be here.
All right. And when we come back, Blair will sit down with the Director of Earth and Sciences Division at NASA Goddard, Mr. Jim Irons.
We're very pleased to speak with Jim Irons, the Director for Earth Science Division at NASA Goddard Space Flight Center. And Jim, can you tell us about the history of this incredible Landsat program?
Yeah, Blair, the program will reach its 50th year next year in 2022. It began with the launch of Landsat 1 in 1972, and since then we've launched a sequence of Landsat satellites, and at any time there has always been at least one Landsat satellite between 1972 and present in operation.
That's pretty impressive, and it seems like scientists can benefit a lot from data, and this has been, what I understand, one of, if not the longest data record that NASA has gathered from space. Is that accurate?
That's true. We claim it's the longest record of the Earth's surface as observed from space, and it is preserved by the U.S. Geological Survey at their archive at the Earth Resources Observation and Science Center in Sioux Falls, South Dakota.
Tell me a little bit about how Landsat gathers its data. When they look at a given particular space on Earth from space, how often does that occur? What kind of data are we getting? Help me out here.
The Landsat satellites are maintained in a near polar orbit so that they are collecting data that measures the amount of solar energy reflected from the Earth's surface. And the satellites all travel from north to south over the daylight portion of the Earth, and then go back from south to north over the nighttime portion of the Earth. As they orbit, the Earth turns underneath the satellites, basically, and there is a consistent pattern so that once every 16 days, a Landsat satellite will fly over the same ground track on the surface of the Earth. And there's a pattern that builds up so that every point on the Earth, with the exception of a couple small areas at the pole, all come within view of the satellite over that 16-day period.
Oftentimes, Landsat satellites work in concert with one another. In other words, Landsat 8's not going away. It'll be working with Landsat 9. Can you explain this?
That's right. They're in very similar orbits, but those orbits are offset by 8 days. So right now, Landsat 7 and Landsat 8 are in operation. After the launch of Landsat 9, Landsat 7 will be retired. Landsat 9 will go into that same orbit, and those ground tracks are offset by 8 days.
It seems like these observations that we get from Landsat are critical when it comes to natural and man-made disasters. Tell me a little bit about how they perform. I mean, I got to be honest with you. I just saw the other day Landsat 8 pictures from a fire in Spain. So it's incredibly relevant and important. How is this helpful to scientists as well?
It is incredibly important. With the 8-day coverage, were not necessarily useful for real-time response. However, what the data are very useful for is before a disaster, the scientists and the land managers can look at the vulnerability of an area and determine whether the prospect of a natural disaster exists. And then after a natural disaster occurs, the satellite will come over and can be used to assess the damage and help with disaster recovery.
very important stuff, obviously, as we encounter these kinds of situations. And I'm wondering, what comes after Landsat 9? Are you planning Landsat 10, 11, 12?
Yes, we have the follow-on system for Landsat in what's called the pre-formulation stage, also known in NASA jargon as pre-phase A. So NASA Goddard Space Flight Center was directed by NASA headquarters to initiate pre-phase A studies. We are right in the middle of those studies, determining what the future architecture for the follow-on observing system will look like.
I'll tell you, we're incredibly excited to hear about all the things Landsat 9 is going to bring to the table, and whatever's next for Landsat, we're excited and hope to be there. Thanks so much, Jim, for being on the show today.
Okay, it was my pleasure, Blair. I'm always happy to talk about Landsat.
Right now, I'm joined on set by Jason Hare, who is the Tiers 2 Instrument Project Manager. Good morning, Jason.
Hey, thanks, Franklin.
Can you tell us about the two science instruments on Landsat 9?
Sure. There's the Operational Land Imager 2, which images the Earth in the visible and shortwave infrared. And there's the Thermal Infrared Sensor 2, which we call Tiers 2, which images the Earth in the thermal infrared wavelength range.
Now, you know all about Tiers 2. Tell us a little bit more about that instrument.
Sure. So all objects emit energy based on their temperature. And the hotter an object is, the more energy it emits in the thermal infrared wavelength range. And so the Tiers 2 instrument uses a telescope to focus that energy onto a detector, similar to how your digital camera works. And that detector turns that light energy into an electronic signal that the electronics can read and then transmit to the ground as science data.
See, this is Tiers 2. What improvements were made to this science instrument over the original Tiers science instrument?
Sure. Tiers 2, built on the Tiers instrument that's flying on Landsat 8, but made two areas of improvement. First one was in the area of performance. So the performance of the telescope was well characterized, and we ensured that we eliminated and minimized stray light that could negatively impact the science measurements. So we will have improved accuracy on Tiers 2. And the other area is in robustness, targeted at ensuring higher reliability system to meet the mission life. We added a set of redundant electronics to make sure that the system could survive a single point failure and continue to meet science objectives.
Is there anything specifically that you're looking for to data that you're looking forward to see from Tiers 2?
Yeah, so Tiers 2 really is going to help the Western states assess water use management, which is a critical, especially now with climate change and how scarce that water resource is. Tiers measures the water usage around the world and helps many countries better manage the resources to make sure their crops can grow, but maintain their water. It also helps monitor the health of the forests. We can track deforestation and just changes to our the land environment to help us make better decisions.
Awesome. Jason, thanks for being on the show, and we look forward to a successful launch.
All right, thank you very much.
Right now, we're going to look at an interview that Blair did with a member of the Landsat science team.
Joining us now is Nima Parlavan, a member of the Landsat science team. Nima, can you talk to us about the basic scientific mission for Landsat 9?
So Landsat 9 will essentially continue the mission of Landsat. It's going to continue observations through the Landsat program, continue to make measurements very similar to the measurements made by Landsat 8, with some enhancement, of course, in terms of the precision of the measurements made over targets, dark targets like bodies of water, and we're going to be seeing those improvements when we do water quality monitoring.
As a result of the improved instrumentation on Landsat 9, can you tell us what we'll learn about water from these observations?
Generally, optical remote sensing would enable us to basically monitor and study optically relevant water quality indicators. These indicators include concentrations of pigments, concentrations of sediment, concentrations of particles or their absorbing and scattering properties. Generally there are two types of particles in the body of water. There are organic material or inorganic materials like sediment. Elevated concentrations of sediment, for instance, increase the temperature of the body of water, which could be detected from Landsat 8 and 9. There is also another parameter that we can quantify from Landsat 9 and 8 missions, and that's colored dissolved organic matter and its absorption. It's basically the amount of carbon in the body of water. Landsat 9 will even offer more precise measurements. We're expecting about 20 to 30% improvement in the quality of observations and its repeatability and consistency of measurements, allowing us to capture basically the dynamic aquatic ecosystems in coastal areas and lakes, reservoirs, and rivers.
Well, thanks so much, Nima, and we're looking forward to an incredible launch and lots of awesome enhanced data from Landsat 9.
So Jennifer, in advance of tower rollback and the launch of Landsat 9, what are you and your team doing to prepare?
Yeah, so before our tower rolls back, we'll be working and evaluating all the systems on the launch vehicle and on the tower to make sure that we're ready to go. We'll also be looking at the weather forecast to make sure that we have good predicted weather for our launch attempt for the day and that we're putting our vehicle outside in a good condition. So we'll be looking at all those things before we give a go to roll the tower back.
Now, this launch has a tower rollback, but in the past we've done launches where the vehicle actually rolls out to the pad. What determines which process you use for the launch vehicle?
Yeah, it's really dependent on the launch infrastructure around your launch vehicle. Atlas is kind of unique because we do it two ways. One, out on the East Coast, we have a vertical integration facility that's a fixed facility, and then we have a mobile launch platform where we stack the vehicle on and then we roll the whole vehicle and platform out to the pad. That's where we have all of our commodities, propellants, and things like that. Here out on the West Coast, we have a mobile service tower, and that's a building that moves. And then we actually stack the entire vehicle and the spacecraft on the pad directly while the building is around it. And then before launch, we'll roll the building back to be clear of the vehicle for launch.
As a mission manager, when are you appointed the duties to oversee a mission like Landsat 9?
Yeah, so for most missions, we typically get put on contract for a mission about 2 years out, sometimes more, sometimes less. And that's usually when the mission manager gets assigned for a mission. I've been the mission manager for Landsat 9 for about 2.5 years now. So when we get assigned as mission manager, that's when we start pulling together a team of engineers out at our Denver engineering facility and then at the launch site. And those will be the people who are doing all the analysis and prep and planning work to get the mission out to the launch pad.
Okay, so after launch, as a mission manager, do you just walk away? Are you free and clear of your responsibilities, or does it kind of go on for a little while after launch?
So I would love for it to be done as soon as we see that vehicle separate, but for me, I do have a little bit more work afterwards. We'll be working on post-flight after the mission, making sure that the vehicle operated nominally. Really important that we understand that the vehicle worked right before we head into the Lucy campaign next. And so we'll be doing that. We'll be putting together a post-flight report. We'll be coordinating with our NASA teammates to make sure that they agreed with the performance of the system and that everything worked as they expected as well. And then we'll be cleaning up, launch contract type items and stuff. So it goes on for like a month or two after launch, but not too much longer.
Well, that sounds great. Hopefully you'll be able to get some time to yourself so you can kind of relax and unwind after the launch. Jennifer, thanks for joining us today.
Thank you.
Joining us again is Mick Woltman. And Mick, I'm looking at the footage here. That's the rocket there, towers rolling back, and it's going to be lit by morning sunlight here shortly.
Yeah, absolutely. With this being a morning launch this morning, no spotlights on the rocket. We'll wait for sunrise to come up and illuminate that mighty Atlas V, get ready for launch.
Well, I have a question for you. And thinking about this, normally we've done rollouts and rollbacks, but it's usually 24 hours, sometimes even 48 hours before launch. This is, to me, an aggressive time frame. I mean, we're 5 hours from launch.
Yeah, this is actually normal for a West Coast mission. With a pad that has a mobile service tower, we can do this at this time frame because we just have to move the mobile service tower from what we call the service position where we work on the rocket to the park position for launch this morning. What you're thinking of is when we launch from the East Coast, we have to roll the Atlas V out from the vertical integration facility out to the pad, do some work with the rocket prior to launch. So we do that usually 24 hours ahead of time so we can get RP1 and everything loaded here. So a slightly different concept of operations with the design of the launch pads.
Now, I understand, like in the case of being a rollback, or roll out rather, you usually come out of a vehicle integration facility. So mobile service tower versus VIF, is there a preference or can you do the exact same thing capability-wise?
Yeah, the team can do the exact same thing. They prep the rocket in the mobile service tower out here in Vandenberg or in the vertical integration facility at Cape Canaveral Space Force Station. And then it's just a matter of what they need to do on launch day. So like we said, roll out early so you can prep things at the pad. Where here on the West Coast, they can continue doing all their work, and then we move the mobile service tower early in the morning, 4 hours or L-5 hours prior to launch.
We have these different holds in the launch. So what's left now for, not many people are going to be dealing with the rocket at this point once it's rolled back.
Yeah, once we get into that T-minus 2 hour hold, they're actually going to clear the launch pad. Everybody will be gone, and then the launch teams will control and do all their work from the launch control centers here at Vandenberg Space Force Base. And the teams will begin cryogenic tanking. They'll start loading LOX in the Atlas, loading liquid oxygen and liquid hydrogen into the Centaur. And then once those are all completed, in parallel, they'll be doing avionics checks and some other vehicle checks. Once that's all done, we'll get into our T-4 hold, where the team, that'll be a 30-minute hold where the team will be able to assess everything, make sure everything looks good, that they've got everything completed prior to going into what we call terminal count, getting down to our launch this morning at 11:12.
It's amazing. And so what are the final things for the guys that are like actually in the mobile service tower that's still moving back from what I understand, and it has to go back like approximately 300 feet?
It's about the length of a football field. They have to go back, and once they get back there, they will have to secure the mobile service tower in its position. So just prior to moving, there was a lot of preps done, and the team had to lift or jack up the mobile service tower, get it on the rails, move it back. They'll have to do the same thing. They'll jack it down, secure it in place, basically pin it with some big, huge, large bolts, if you will, and so that it is in place for launch this morning. Once that is all done, the stand engineer and the team that's out there will secure the pad, make sure everything's ready to go, make sure all valves, ground valves and everything are in the proper position, verify those things, and then they'll leave the pad and turn it over to the launch team in the Launch Control Center.
For those that are going to stick around for launch coverage, how are we looking for the rest of the day?
So weather today is looking really good. Captain Nichols gave us the weather report early this morning, and things are looking really good. We are less than 10% violation, which means we're greater than 90% go today. So let's hope that the weather and the marine layer stays doing what it's doing here in Vandenberg, and we get to that launch time of 11:12. Excited about that launch this morning and the continuation of the Landsat mission.
Thanks so much for being on. You're watching NASA Edge, an inside and outside look at all things NASA.